we're back for another video, and this one is going to talk about complex numbers. For some of you, this is going to be very new, not something that please listen carefully, take some good notes, and again, jot down what you have as I go along. Now, our vocabulary for this unit, we're going to talk about what's called an imaginary unit. What's a complex number? What's an imaginary number? What is a complex kind? We may or may not get that covered, but I may at least just give you a little brief of it. And then what's a complex conjugate? So very similar to the conjugate that we talked about with radicals earlier on. So let's go ahead and get started on those. Okay, so in our last video, we talked about radicals, how to simplify a radical, how to do radicals in the denominator and rationalize them and so forth. And one of the things that we talked about within all of those is positive radicals, okay? Because we know that it takes two positives to make two positives or two negatives to make a positive. But the question happens to be is what happens if when I work a problem and we're doing an x squared problem and I have it as a -4, okay, x squared equals a -4. And so for the most part, you're going to say to yourself, well, that can't happen, right? Because I know that 2 times 2 is 4, and I know that a -2 times a -2 is 4, so there's no way to get a -4. So there needs to be something for us to do to kind of bypass that. So when we take the square root of both sides on this, and I get x has to be the square root of a -4, instead of saying that it is no solution, it's no real solution. Okay? In other words, there's no real number that we've talked about that will work because we talked about 2 and a -2. But what will work is what we're going to define as an imaginary number will work. Okay? And so our imaginary unit that we're going to talk about is the square root. How we've defined it is -1, because of the fact if you take this here and I break apart like what we did earlier into a square root of a -1 and a square root of 4, then I can in fact, let's take the square root of both sides, then in fact I can say that the square root of this here, the square root of 4 is 2. But what am I going to do with that square root of a -1? Okay, and so how we've defined it so that I know in this problem, how do I know that that was not the square root of 4, but in fact the -4, is that we use the letter I, meaning imaginary. Okay, so the square root of a -1 is defined as I, as an imaginary number. And so this in fact would be, as a final answer, either a positive or negative 2i, okay, 2i on that. And that's how we're going to define it. Now, we'll talk about the graph of it, we'll set it on the graph and what it tells us in terms of graphing later on. But just to introduce you to an imaginary number, that's where we're going to see it. I want you to make note of what I put on here because you'll be asked questions in regard to this piece of it. But when we talk about the square root of a -1 is I, we also look at all the time, well, what happens if I had an I squared? Okay, so I want you to think about it. And that would mean I would need a -1 squared, right? And if you remember, the -1 or the square root and square cancel each other, this is actually going to be just a -1. Okay, now maybe that didn't make sense to you. So remember what squared means, times itself. And from our last things that we were doing with radicals, anything times itself under the radical is simply what's under the radical, the -1. Okay, so an I cubed now would really be 3 of those. So I would have the square root of a -1 times the square root of a -1 times the square root of a -1. Know that 2 of them together is a -1. I know one of them, so this is actually a -I. You're like, what in the world is she doing? Right? Okay, I4, okay, that means you're 1, 2, 3, 4, all multiplied together. But we know in groups of 2, that's a -1 and a -1, which is 1. Okay, now here's a cool thing that happens though. When I go up to I5, and I have 5 of these, It's written out all 5. They're like, what in the world? Again, 2 of them is a -1. I got 2 more is a -1. Okay, let's just back up. Instead of saying 2, well, let's just keep going with what I got. We got a -1. And then I've got 1 more, which is an I. So I really have -1 times -1, which is 1, times I, again, which is just I. And I'm actually back up to the beginning, okay, up here. So what actually happens with imaginary numbers is that in terms of powers, they repeat every 4. So you will never go past what an I4 is, okay? So when I go back up, this would be the same as an I5, an I6, an I7, an I8, and then I back up an I9, an I10, I11, I 12. Now, some of you may not catch on to what I just said there. That's okay. That's okay. We'll talk more about it later on. But it does become a very, very interesting little fact that we quickly tell you to kind of memorize how this works. And I'm just going to make you a little box over here to the side. Okay, my face is right in the middle of it. So, okay, and so here is our rule. Okay, is that I is the square root of a -1. Okay, I squared, read that, I squared is a -1, I cubed is a -I, and I4 is 1. And again, and then it would repeat itself over and over and over again. Okay, so that's a lot of stuff. But for the most part, if you can memorize the first one, and if you can remember the last one, you're pretty good. Okay, so let's move to imaginary numbers. Okay, so I'm just going to work through a few problems here with you. So if you had to all I'm having you do here is just simplify these problems. Again, I see the square root of a -16. Normally you would say no real numbers, but we're going to break it apart just like what we did earlier when we simplified radicals. And I'm going to take the -1 out and leave the 16. I know the square root of a -1 is I, and the 16 is 4. Write this as 4I. Now they always write the I second, not first. On there, if you do I4, it's not wrong. It's just this is the way that they write it. Okay? So the square root of 200, we've done that one before. So it is, let me go back. So it'll be, again, the square root of a -1, square root of 200. We know that the square root of 200 is the square root of 2 and the square root of 100. So let's look at what we have. We know square root of 100 is a perfect square. It's 10. We know that the square root of 2 can be simplified. And we know that the square root of a -1 is I. Okay? Now, that is the correct way to write it. Okay? You'll rarely see it written that way. And it's written that way because this is your number, and then you've got the I. But it is very common to see it written this way, 10I square root of 2. And the reason they write it with the I in between is because if you don't put parentheses around the 10 radical 2, it looks like I could be underneath the radical, and we don't want it to look that way. Okay? So you have 2 choices here, guys. You can either put parentheses around your number, especially if it's a radical. If it's not a radical, then you can do like the 4I. Or put the I in between the 2. But in actuality, we'll talk about what a complex number is in a little bit. The I should be on the outside. Okay? Next one. You'll remember earlier on we talked about multiplying radicals. Let's have the square root of 3 times the square root of 5. I said you could just multiply. Okay? But I also said that was only true if those numbers were both positive. That does not work with negatives, guys. With imaginary numbers, that's not going to work. So you do have to pay attention here because this is going to mess you up if you don't. We do need to go ahead and work, we do need to go ahead and work with the imaginary number. Okay? So again, I'm going to write this as the square root of a -1 times the square root of 4. Square root of a -1 times the square root of 9. Okay? Now, when I'm looking at this, the square root of a negative 1 is I. The square root of 4 is 2. The square root of a negative 1 is I. And the square root of 9 is 3. Okay? From back what we did earlier, we have 6I squared. Okay? Now that is not considered in simplest form though. Okay? Because if you'll remember in your notes, back up, what was I squared? Okay? And I squared was a negative 1. So we really have 6 times a negative or a negative 6 as my final answer. So anytime you have more than an I to the first power, in your problem, it can be simplified down. So you're going to go back to that list that I gave you of the 4. Okay? Okay? Okay, let's do another one real quick. Oops. Okay, let's run through another one here. Now this one just has a number out in front, but as far as the square root of 4 piece of it, I still need to break it apart. Okay, so I have the 2, I have an I, and I have a 2. 4I. I'm just going to multiply it. 2 times 2 is 4, and then the I. Okay, let's talk about adding and subtracting. Okay, adding and subtracting numbers with the I, that's just like with an X. Okay, you're going to just combine like terms. Very easy, nothing new here. So in this case, I would have 2 and 4 is 6. I have a plus 3I and a minus 5I, which is a minus 2I. Okay, that's all you got. And this, guys, will be called our complex number in just a little bit when we talk about it because of the fact that it has an imaginary number and real numbers. Okay, let's do a minus. Now, if you got a minus, I would probably change signs. Minus 6 plus 7I. If you can keep track of it, that's great. So I have 5 minus 6 is a, whoops, sorry, keep hitting that, negative 1. And a negative 2I and a plus 7I would be a plus 5I. Okay, that's all you got to do. Okay, so our video is getting a little long. We do have a couple more things to do with multiplication, but we'll do those in another video.